So, is it visible to all of you?
Yes, sir,
Yes,
visible.
sir. Yes, sir.
Yes,
Okay.
yes, sir, visible.
Okay. Suppose first we'll design this type of circuit and we'll give the appropriate values to set the biasing. Okay, for to operate this transistor in an active region, we have to set appropriate value of these components. Then we will observe the input waveforms and what will happen at the output we'll see. Okay, and we'll do different types of analysis like tangent analysis, DC analysis, AC analysis, and this thing we'll do in next class. Okay, just it is quite interesting. This is your input signal. Then add another plot play pan, and you'll get the output signal. Okay, input, as you can see, input signal in terms of millivolt and output signal in terms of volt. That means it is increasing.
Amplified.
Amplified. Okay, good. So this type of hands-on experiment we will do on coming Friday. So let's talk about the theoretical part of this amplifier, and then we'll go for this type of hands-on experiment, and we'll analyze the output, what kind of output we are getting. And if we perform the AC analysis, if we perform the tangent analysis, if we perform the DC analysis, so this type of it will be more interesting. Okay, so and end of the session I'll attend your questions. Otherwise, what will happen? So the whole flow will be break. Okay, and because if too many questions will come during my lecture, then I won't be able to complete whatever I'm targeting. So I'll give you some time after end of this lecture, and that time I'll attend your questions. Fine.
Okay, sir.
Okay.
Okay. So in my last class I talked about a single stage amplifier little bit. Then today I'll finish this part. Then I'll move to next component, that is classifications of amplifiers. Then we'll talk about the deep dive into common mode amplifier, common emitter amplifier. Then I'll talk about real implementation, and then we'll solve some problems. Okay, and I'll provide the solution accordingly. So voltage divider circuit already we discussed in last class. So primary reason to introduce this type of circuit, we'll see if we remove this type of voltage divider circuit, then what will happen at the output in next session. Primarily we have to operate our transistor in an active region. So for that we introduce this type of additional circuitry for stabilize the circuit. Okay, otherwise circuit will be unstable, will not get stable output. So stability is one of the essential component in case of analog IC design or analog circuit design. So before that, I would like to tell you one thing. Okay, at the end of the lecture I'll tell you. So here you can see in this circuit there are a couple of components are there, like R1, R2 and emitter resistors, and these are basically forms biasing and stabilization of the circuit. That's the only purpose is to provide a particular voltage so that transistor will be operated in a active region or will be in a forward bias. So that's the reason to introduce or to include all these components. So primary reason is we have to achieve some gain, because as an input we are receiving weak signal. Somehow for real application, if you want to use this realized for a practical applications, then you have to enhance, you have to magnify that signals. And that magnification or amplification we can perform with the help of this type of circuits. Now input capacitor, we are here basically one additional capacitor is there at the input side is one capacitor is there, that is Cin. You can call it also coupling capacitor, because it is it couples basically input signal to basically base of the transistor. This is the input side. And look at this output side, there is another capacitor, that is coupling capacitor. That is another coupling capacitor. And if we don't give this this coupling capacitor or Cin, then what will happen? Then DC signal will come here. Already weak AC signal is there. Some distortion will take place. Means whatever we are targeting will not achieve it. Simply we can say. Another thing, what will happen? So if suppose this capacitor blocks basically the DC signals. It will only allow AC signals. It will only allow input signal. So another, if the capacitor is not present, then input signal will go here. Then which changes the bias at R2 simply. And we'll see whenever we'll do some hands-on experience with the help of Ltspice simulator, we'll remove this capacitor, then we'll see what will happen. Similarly, we'll remove this another capacitor which is inserted across the emitter junction. So let's talk about first this.
Sir, I am not able to understand the second point of input capacitor. What do you mean by isolate the signal source?
Hello.
Hello.
So
Sir, I'm not able to understand.
I'll attend your question at the end of the talk.
Okay, sir.
Okay. So please write it down. Okay. I'll explain it. Okay. So now coupling capacitor. So as you are asking, let me tell you. So this capacitor helps to basically blocks the DC signal. It only allows the AC signal. First thing. If we not consider this capacitor, then input signal will be directly impacted on this here in case of R2. Bias at R2, then the whole thing, if bias of this resistor will change with the help of this input signal, then circuit will be unstable. At the another side, if we not consider this input capacitor, then some DC signal will come here. Some DC signal will come here, then distortion will take place, because already this is weak signal. Or some impedance will add. Then whatever we are targeting, suppose we are targeting calculate the gain with respect to the input signal, then we will not achieve it.
Okay, sir.
So another thing is coupling capacitor. So this is similar concept. But we are inserting this capacitor at the output side. And why we are inserting? To connect the another stage. Okay, and it as it couples two stages. So if we consider another stage over here, as it couple two stages, so that is this capacitor is known also coupling capacitor. It also, so role of all the capacitor here, whatever capacitor we are considering across the emitter, output terminal and input terminal, all will blocks the basically DC signals and allows the AC signals only. So if we remove this, capacitor across the emitter, so then you'll observe that from the output waveform that amplification will not take place, whatever we are targeting with the help of the circuit. So due to the presence of coupling capacitor, output across the load resistor is free from the basically collector's DC voltage. So it blocks the DC signals. So it will be free from the DC voltage, collector DC voltage. Otherwise, DC voltage will take this path. And if not present, then it will be directly drastically impact on the basically the next stage that is known as shunting effect. So shunting effect, due to shunting effect, it lost the electrical current or electrical characteristic. It will change the electrical characteristics of secondary circuit provided. So to avoid this kind of situation, to avoid this kind of these circumstances, we shall consider this type of coupling capacitors. Similarly, in case of emitter bypass capacitor, this capacitor is employed in parallel to the emitter resistor, that is RD. As you can see from this figure, so one additional capacitor has been introduced in parallel with the resistor RD. So what will happen? It bypass basically amplified AC signal will be bypassed through this capacitor. Otherwise, what will happen if this capacitor will not present? Then signal will pass through the resistor. Then a significant voltage drop across the basically significant voltage drop will take place at the resistor RD. Then it will also connect to the feedback to the input signal. As you can see, then reducing the output voltage. The overall impact will be it will reduce the output voltage. So another parameter is there, that is load resistor. As you can see from this figure, the load resistor RL connected at the output as a load resistors. So whenever you will connect this amplifier is connected to another stage, or will go into as an input of another stage, then basically that this load resistor will act as an input resistor. So as I have mentioned here, so when the number of stages are used, then load resistor RL represents the input resistance of the next stage. So now various circuit currents. So there are two types of analysis primarily. One is AC analysis, another one is DC analysis. So AC analysis. So in case of let's talk about various types of current will flow in this circuit. When no input signal is applied to the base terminal, then what will happen? Sorry. When no signal is applied to the base terminal of this transistor, then but we have already but bias signal or DC signal is already we have applied. Then DC base current, so due to this DC supply, DC base current will flow. DC base current will flow. Okay, and that is known as IB. And due to the biasing circuit, this biasing circuit. So when AC is absent, when this signal is absent, so one current will flow, and due to this biasing circuit, and that current is known as basically capital IB. Now we are applying AC signal. Now we are applying AC signal. So in addition to the DC base current, that is capital IB, due to this AC signal, so another small amount of current will flow due to this AC signal. So that is known as AC base current, and we can represent this by small IB subscript B. Also flows. So therefore, at the base terminal, we can see the total amount of current would be, one is IB plus small IB. One is DC base current, another one is AC base current. DC base current due to the biasing, and AC base current due to the AC signal. So this is all about the in case of base current. So same thing happened in case of emitter current, in case of collector current. Let's see. So when no signal is applied, in the no AC signal is applied here, then due to the biasing, the IC will be flow, DC collector current. We can represent with the by IC due to the biasing circuit. Then we are applying the AC signal. Then in addition to the DC collector current, that is IC, another due to this small signal, this is AC signal, another collector current will flow, that is IC. So total amount of current at this collector terminal would be IC plus this is DC collector current, and this is due to the AC collector current. And these two formula already know by convention, that is IC equal to beta times IB, zero signal collector current, or and in case of DC, in case of AC, IC equal to beta times IB, collector current due to the signals. This is due to the biasing and due to the signal. So now emitter current, similarly, as we have seen the total amount of current in case of base, total amount of current in case of collector, same thing will take place in case of emitter also. Same thing will take place in case of emitter also. So emitter total emitter current is basically IE, DC emitter current, when no signal is applied. So don't mix up the both analysis, DC analysis together. Don't consider, otherwise you'll be confused. Now a DC emitter current is IE, and if we apply some AC signal, then small amount of current will flow due to the AC signal, that is small IE. Okay, so total current we have found for different terminals, that is IB, IC and IE. Now by convention, we know that IE, emitter current here is a combination of IB and IC in case of DC. Similarly, in case of AC signal, we can write I equal to IB plus IC. But this signal is very small. Base current is very small for both cases, very small. Then we can simplify this. We can't ignore it. But for simplification, we can say that I is approximately IC, because if base current is, this current is very small, and usually then I equal to, in case of DC, in case of, we can write I equal to IC, in case of AC we can write I equal to IC, if we ignore the small amount of base current for simplifications. So this is all about the practical circuit of a transistor amplifier or single stage amplifier. Now there's some important concept we have considered so far. Now let's talk about classification of the amplifiers. Once we finish the classification of the amplifier, then we move to the basically common emitter amplifier. So amplifier circuit is one which it basically increase the signal strength. We are giving the input signal, weak input signal, and at the output terminal we are getting high output signal. But based on our target application, we have to fix it out rest of the parameters. We have to fix it out rest of the parameters. So let us try to understand the classification of amplifiers. And amplifiers are classified according to many considerations. A couple of considerations are there. It's a very vast topic in electronics. There are lots of different types of various types of amplifiers are there. Now we have to select that, okay, I'm going to target, suppose for example, audio applications. Then which type of amplifier you should use? I want to design a basically transceiver. Then which type of amplifier you should use? So based on your target application, so always think about, okay. So it's all about each and every circuit has practical applications. It's not about just you understand the operation and circuitry and all that and that is not enough. You have to think about like this way that okay, if I change this, then what will happen? And if I targeting this application, then what kind of configuration we should consider and why we should consider and what would be the appropriate value of the rest of the components. So depending upon the number of stages of amplification, if any amplifier consists of a single transistor, it is called basically single stage amplifier. But if it is more than one transistor or more than one stage you are considering, that is known as multi-stage amplifier. So this is based on the number of stages. Now based on the outputs, what kind of output you want? Voltage amplifier, power amplifier. So there are two categories, two types of amplifiers are there based on the outputs. Its outputs. One is voltage amplifier, another is power amplifier. Means amplifier circuit that increases the voltage level. Suppose you are giving 10 milliwatt at input and you are getting 100 milliwatt at the output, and that is basically voltage amplifier. Then power amplifier. Similarly, output power to the input power, output voltage to the input voltage, output current to the input current. So the amplifier circuit that increases the power level of the input signal is known as power amplifier. So first thing I talked about in terms of number of stages, in terms of number of transistors. Second thing I talked about which type based on the output, what kind of output you want for a particular applications. That is voltage amplifier and power amplifier. Now, based on the input signals, so based on the input signal, there are two types of basically amplifiers. One is small signal amplifiers. Second one is large signal amplifiers. So when the input signal is so weak, as you can see from this name, small signal. When input signal is so weak, and that produces small fluctuation at in the collector current, and that compared to the quotient value or Q point, and that amplifier is known as basically small signal amplifier. And if your input signal is quite large, means when the fluctuation is in collector current as large beyond the linear portion of the characteristics, and that type of amplifier is basically known as large signal amplifier.
So
if it is
characteristics.
I'll explain it, okay, with the waveforms later. So linear means suppose you are applying something input over here, and you're observing the output. If your output increase basically linearly, okay, linearly. This is known as linear portion of characteristics. Linear. So there are three types of region. One is cutoff region, second one is active region, and third one is saturation region. Okay, that thing we'll discuss in next class. Okay.
Okay, sir.
Okay. With the help of basically, first I'll talk about the basic theory about the output characteristics. Then we'll go for the hands-on experience. Fine. So now based on the frequency range, there are audio amplifier. It is most useful, and power amplifier. This is also nowadays most of the company they are working on it. Okay. So audio amplifiers, so based on the frequency range, if you are designing your amplifier within this range, you can use this amplifier for the audio applications within this range. And if you are designing your basically amplifier for high frequency range application, that is will be used as a power amplifier. In terms of frequency range, we can divide amplifier into two types. One is audio amplifier, second one is power amplifier. Sorry. Based on the biasing conditions. So first I talked about number of stages, then I talked about voltage amplifier based on the output, then I talked about in terms of input signals, then I talked about frequency range. If it is small within this range, then it is called audio amplifier. If it is high frequency range, then you are going to design for high frequency range, that is known as basically power amplifier. Then based on the biasing conditions, so based on the biasing condition, there are three types of basically amplifiers: class A, class B, and class C amplifiers. Now let me tell you what is class A amplifier. So I missed one point, that is so application of each type of application I should add. Okay, that thing I'll add in the slide. Okay, later. So there are class A, class B, and class C amplifiers. So and another type of amplifier is class AB amplifiers. So class A amplifier, basically the biasing condition in class A power amplifier are basically such as that the collector current flows the entire AC signals. We are providing the AC signal as an input. So we are providing the AC signal as an input. So if the biasing condition in this amplifier, the collector current flows through for the entire AC signal, that is known as basically class A amplifier. If you are considering basically half cycle of the input signal, either positive or negative half, and that is known as basically class B amplifier. So in case of class A amplifier, you are considering both cycle, positive and as well as negative cycles, collector current flows. And in case of class B amplifier, collector current flows for the half of the input signals applied. In case of class C, less than half of the input signal, less than half of the input signal, some portion less than half of the input signal, you are collecting data from less than half of the input signal, that is known as class C amplifier. If you couple class B and class A amplifier together, then that is known as basically class AB amplifiers. And this is there are some couple of applications are there for this type of all types of amplifiers. Okay. Now based on the coupling method, that is RC coupled amplifier. So in case of RC coupled amplifier, transformer coupled amplifier, and direct coupled amplifier. So RC coupled amplifier, a multi-stage amplifier circuit is coupled to the next stage using the resistor collector combination can be used for RC coupling. If you are considering the RC resistance and capacitance for the next stage, so that is known as basically RC couple amplifier. If you are considering transformer, that can be used as a transformer couple amplifier. If you are considering couple the next step directly, okay, directly without RC, without transformer, that is known as direct couple amplifier. So based on the coupling method, we can divide into three categories. One is RC, transformer, and direct couple amplifier. Oh, sorry. So now next one is transistor configuration. So based on the transistor configuration, we can divide into common emitter amplifier, common base amplifier, common collector amplifier. Here common means emitter is common in between input and output, that is known as common emitter. Base is common in between input and output, that is common base amplifier. And collector is common in between input and output signal, that is known as basically common collector amplifier. Okay, so based on the biasing condition, these are three types of transistor configuration, means placing of the transistor. So three types of transistors are the amplifiers are there. One is common emitter, common base, and common collector. Just difference is that that position of the emitter terminal, position of the collector terminal, and position of the basically base terminal. If you are considering the emitter in between input signal and output signal, that is the common emitter. If you consider base in between input signal and output signal, that is considered that is known as basically common base. If you consider collector terminal in between the output and input and output signal, that is known as basically common collector amplifier. But based on the syllabus, mainly we'll focus on common emitter amplifier. Common emitter amplifier. Let me tell you briefly about it. The amplifier circuit that is formed using common emitter configured transistor combination is called basically common emitter. So as you can see, so this is basically input side, this is input side, this is input side, and this one is basically, if we connect this one basically output side. This is basically output side. Here you can see the emitter terminal is common in between basically input and output, and that's why it is known as common emitter amplifier. So common emitter amplifier circuit using the NPN transistor. As you can see, this is the NPN transistors. Okay, so the input signal being applied at the emitter base, input signal is applied in between the emitter base, and output signals are being taken from the collector base junction. From the collector base junction, output signal is taken from the collector base junction. That is known as basically common emitter amplifier. Okay. Now there are a couple of concepts are there. So emitter base junction is forward bias. Emitter base junction is forward bias. And collector base junction is basically reverse bias. Collector base junction is basically reverse bias. And operating point is adjusted with the help of the basically RE, that is emitter resistance, and RC. This operating point is also adjusted with the help of these resistors. And the values basically IC, IB, ICB are decided with the help of basically VCC and collector base junction and emitter base junction voltage, that is VE, and then RE, then IC. Now let's talk about operation. So when no signal is applied, when no signal is applied, the quiescent condition are formed. I'll tell you quiescent condition. Okay. And no output is present. No signal is applied. Input signal is applied. Right now I'm talking about. Now, when positive half of the signal is being applied, positive half of the signal is applied, positive half of the signal is applied, the voltage between base and emitter, that is VBE, base and emitter, that is VBE, is increase, because it's already positive with respect to the ground, Now as the forward bias increases, so this will be in forward bias. So forward bias increases, the base current is also increases. That is since we know that IC equal to beta times IB, then the collector current. So the already you have covered this portion, the basic principles of amplifiers. So I'm not discussing too much about it. Otherwise, I'm not able to complete all these things. So as forward bias increases, the base current too increases accordingly. Since IC equal to R, we know that IC beta equal to IC by IB. Okay, IC by IB. Okay, and the collector current increases as well. Okay, now when the collector current when flows through RC, when flow through the RC, then voltage drop increases. Now, as a consequence of this, the voltage between collector and emitter decreases because voltage drop increases. Okay, so voltage between collector and emitter decreases because we know that VC equal to IC RC. Okay, IC RC. So then amplified voltage appears across basically RC, or we can write the output voltage VCC minus VCC was supply voltage minus this voltage drop. It's total output voltage I'm talking about. Now there is a point is there. As since the collector voltage of common emitter amplifier, that is VCC equal to basically ICRC, and increases at the IC results drop across the collector voltage. Already I told you. But when the positive input signal you are applying, when the positive input signals are applying, when the input signal is positive direction, output goes in the negative direction. Because voltage drop increases. So we get the negative half cycle output. Output voltage for the positive half cycle as an input. So therefore when it will go into negative, then we will get the positive cycle at the output. That means if we compare the input signal and output signal, there is a phase difference that is 180 degree. Why there is a phase difference 180 degree? Because collector current flows through the RC. So the voltage drop increases. As a consequence, the voltage between collector and emitter decreases. So that's why it will go basically negative. Okay. So output voltage appears at the basically RC. It will be total output voltage VCC minus, because collector this voltage drop already know, that is VCC equal to IC RC. Okay, that's the reason. Basically there is a phase shift, output signal phase shift, 180 degree phase shift, because as when it is increasing, voltage drop decreasing. due to the this the voltage drop increasing and the potential difference between basically collector and emitter basically decreasing. That's why we are getting the opposite waveforms as compared with respect to the input input voltage. Okay, so common mode common amplifier so common amplifier has a high input impedance and lower output impedance than the basically common base amplifier. The voltage gain and power gain are also basically in high in case of common mode common emitter amplifier. Hence it is mostly used in. So one of the major application of this type of amplifier is we can use for audio amplifier. We can use it for audio amplifier applications. Now let's compare with, so output characteristics of this amplifier I'll talk about on coming Friday with the help of hands-on with the help of Ltspice tool, one of the simulator to simulate the analog circuits. Okay, so now if you compare the, although we are not covering common base and common collector, so it is very difficult to understand so comparison, but just for knowledge I am sharing with you all so that you can have a look common base amplifier and common collector amplifier and design three types of amplifier: common emitter, common base and common collector with the help of Ltspice. Then compare it. So input resistance here it is low, common base very low and common collector is high. Output resistance large, it is high, it is low. Current gain moderate or high, moderate or moderate, less than, so this is B high, beta high, alpha less than 1 and high 1 plus beta. Okay, so this is the concept of current gain. And then, or you can say that it is moderate and voltage gain, this is high. In case of common base this is high, and in case of common collector this is less than 1. And power gain it is very high. Okay, and it is also, and we'll prove it current gain, voltage gain and power gain in next class. Okay, what we are getting, so with the help of circuits. So now phase difference between input and output, because if in case of common emitter amplifier we are increasing basically during the positive half of the input signal, and but at the input side but we are getting a voltage drop across the at the output terminal is increases. So that's why we are getting opposite or phase difference. Output terminal output waveform is 180 degree, there is a phase difference. So but in case of common base and common collector there is no such phase difference concept is there. So now due to the compatibility and characteristics features, the common emitter configuration mostly used in amplifier circuit. So mostly due to the characteristics, due to the features, compatibility, so most of the cases common emitter amplifier is used. Now actually I was talking about just wait. So there is a tool, there is a website just you can download the Ltspice tool. Okay, Ltspice tool, you can design different types of circuits, then you can analyze different types of basically output characteristics, tangent, AC analysis, DC sweep, noise, DC transfer. Okay, this type of analysis basically you can perform. I'll explain what is tangent analysis, what is AC analysis, what is DC analysis in next class. Okay, so suppose in case of tangent analysis and we'll basically observe, so we'll design this single common mode common emitter amplifier with the appropriate value of R1, R2 and RC and RE, and with the help of the coupling capacitor, we'll insert the voltage source and input signals, and then we'll perform, we'll observe the output signal or voltage drop across the basically load resistance. If we reduce the value of load resistance, then what will happen? We'll observe it. If we remove this coupling capacitor across the emitter junction, then what will happen? And also we'll observe the how much gain we are getting. So first we'll fix some parameters or value. Okay, so based on that we'll target that, okay, we want to achieve this much of gain. Then after implementing this type of circuit, we'll see whether we are able to achieve that gain or not. So for that first thing you have to do, you have to download basically Ltspice is one of the spice simulator or one of the software, you can say, to it is mainly used to analyze the analog circuits. It is mainly used to analyze the analog circuits. Okay, you can simulate, and you can generate different types of waveforms with the help of this type of Ltspice simulator, and it is introduced by Analog Device, one of the pioneer company in analog domain. So what you have to do to use this circuit, just you have to download, if you based on your Windows. Okay, if you are using Mac, then you can go for this one. If you are using Windows, then you can 64-bit, then you have to go for this one. If you are using suppose 32-bit operating system, then you can go for this one. Then download it. Then just after downloading it, just install it. Just click on next. Then it will be installed automatically. Okay, it will be installed automatically. Then what you can do, just do the practice before me. Okay, what I can do, you can just new schematic, this type of window will appear in front of you. There's a components are there, like you want to use NPN transistor. Just click on it, then place it over here, then escape. Okay, and then if you want to insert the resistors, then you can insert the resistors over here. Okay, then connect them. This is the connector. Okay, just click on it, connector. This is a move option. If you want to move this circuit somewhere here, zoom in and zoom out you can do by scrolling here through your mouse. Okay, and then you can move it here, then it will looks like good. So design this type of circuit and do some experiments, hands-on experiments. Okay. And connect them together. Connect with ground. So this is for wiring. This is for ground. This is for resistance. This is for capacitance. This is for diode. This is for list of the component. Whatever component you require. If you require the voltage source, just type voltage here. Then you will get the voltage source. Okay. Right click on it to set the voltage. Suppose if you want to give 10 volt, 10 volt will be set. Connect them together. Fine. Then choose capacitor coupling input capacitance. Okay, input capacitance will be like, you can there is another capacitance, there is another capacitance. 3 coupling capacitance are required. So if you want to, you can rotate it. Okay, just select on it. This is the rotate option over there. Rotate option is there. You can collect it. And connect them. This is another one is there. Connect the ground, or you can connect it together. Okay. Input signal. Then connect this component. Then voltage. Ground. Right click on it. Advanced AC signal. Then give some on value. 10 volt on amplitude. This will be AC signal. Okay, then everything is finished, right? Okay. Then save your design. Okay, and then you have to give proper value of R1, R2 and R3. Give the value of R1. Suppose if you want to give value of R1 is 2K, give it, and value of R2 suppose again 10K for example. Okay, just click on it, go there like this way, then right click on it. You can give the value. And similarly, this is now save it. Okay, so you have to save it first, then do the run it. Okay, so run it. You can give the stop time, suppose 10 something like that. So this thing already we will discuss in next class in detail. We'll select the appropriate value, and we'll observe basically different types of waveforms, output waveforms. Okay, and we'll do the analysis, that transient analysis, AC analysis and DC analysis. And okay, in case of common emitter amplifier. So, and then we will solve couple of problems. Okay, then we'll finish my lecture. So this thing I am basically okay, lecture series I'm uploading over here. So if I modify this one, definitely I'll update it. Basic electronics. Okay. I'm uploading it here. Under there will be tab, or I can create a new folder. Lecture notes. Under this lecture note, so you can download this lecture slide from here. Okay. So now let me ask if you have any questions, please ask me. Okay. So to just download, so before tomorrow's next class, just download this Ltspice simulator. Then try to do something whenever you will get free time. Okay. So first you have to do new schematic, and lots of YouTube videos are available based on this Ltspice. You can go through it for more exposure. Okay. Then design a circuit. Okay, whatever circuit, any circuit, then observe the input, give some inputs and observe the outputs, and do some analysis. Okay, otherwise what if I tell you in terms of theoretically, it will not be basically, it will not be basically, it will not be enjoy this thing, or you will not able to learn this thing. Okay, until and unless you will have, okay, if I remove this capacitor, then what will happen? If I remove this capacitor, then what will happen? And what should be the values of, how we can decide the values of R1, R2 and R5 and R3 in the circuit, and what should be the value of standard value of coupling capacitor, so that it will it will not pass it will block all the DC signals. This type of analysis, and what should be the value of load resistance. If I give low load resistance value, then what will happen? Will not able to achieve the whatever you are target gain. Okay. So this type of do some experiments based on this platform, and then definitely you will enjoy it at the same time, and you'll have more exposure regarding this type of circuits. So try to do some practice. Any circuit, try to do some design, and this will help you a lot in future, in terms of research, in terms of higher study, in terms of industry job. There are many more softwares or simulation environments are there. Okay, whenever you'll be in second year, definitely, or if I'll take any course in microprocessor, detail electronics, or VLSI design, and that time I'll discuss all these things. Okay. So now let me tell, if you have any questions, you can ask me.